Hi, good afternoon to everyone. Okay, hello everyone. This is the latest guide to help you to work on your tutorial 2 for those who have some problem encountering doing it. Okay, so I will go through the tutorial 2 in a very snapshot manner, in such a sense that I will do a compressed version of how to go about to solve some of the problems. Okay, for example, in the MCQ, okay, I will go straight into the question. As you can see on the screen, there are two screens here. One is where I can write, which is on the pen, writing pad on the pen, and the other one is the solution approach that I have come up with, which is quite a step-to-step process. Okay, so okay, for the first part where we talk about, let's say if we want to find resultant force, okay, from either two component forces that actually produce a resultant force. Okay, and from this, right, first and foremost, we almost always have the same approach. Okay, first and foremost, we must always acknowledge that the final resultant force, right, is always equals to, okay, there's a vector, right, is equals to the F1, okay, or plus F2, okay, by the direction. Okay, we will always set in this way. Okay, when we are writing a vector, we always write this way. Okay, but when you actually want to put it into context, right, so that means every of these, right, they have their components, they have their x and y, right? So I have one FRX, this is a FRY. So similar for this, they have the x and y component. This is also have the x and y component. Okay, so important thing is, if I have my FRX, it will be the sum of F1 x plus F2 x. Okay, so if I have y component, I will have sum of F1y plus F2y. Okay, so as you can see on the right, what I have written is that this is the simple thing, simple way of doing in terms of rectangular format. So if I have a few different forces here, okay, presuming I have one force this way, okay, this force I will have x and y, right? So let's say if this is F1, so this one will be F1y, this will be F1 x. So if I were to have another line, another force this way, then I have a, let's say for example this F2, then I have a F2 x, I will have a F2 y. Okay, but because of the direction of it, right, where we set the assumption F this way, so something happened is that in the sense that you need to take into consideration this is a negative, this is a negative, because of the direction, right? So if you look at the solution guide provided to you on the left, Okay, take note of this portion especially, okay, whereby I have to tell you that the resultant force is given to you. The F2 is the one that's unknown, right? So what you need to do is, first thing they give you in polar format. Okay, the question gives you in polar format, right? So when you are in polar format, you need to convert it to x and y basis, right? So x and y basis, which is the next format they can use? So it's the rectangular format. So that's the reason why you convert to rectangular form. How to convert to rectangular form? Okay, basically, okay, I clear the board first so that I can do something about it. Okay. Okay, when I'm talking about rectangular format, right, if I have a force polar to rectangular, as what you can see in the solution, force with an angle, right? Okay, how I convert to rectangular format? Basically, a rectangular format, right, I have the force. Okay, this is FR, let's say for example any okay, not to confuse you first, so I don't put the R there. Okay, my problem. Okay, so now if I want to convert it to rectangular format, first and foremost I must have the force, okay, which is equals to I have the cosine element of it, okay, which is theta, okay, and with an I, and then I add a sine component, which is the J. Okay, down here, what you're interested in, right, is this part and this part. This part is the x component. This part is the y component. Okay, so this is the reason why, if you were to look at this side here, what I have done is converting whatever over here, which is a force, resultant force, right, into the respective x and y component for each of these. So this FR will be the component FRX, FRY, and this is F1 because the other force is given to you as 20 degree, right? So and 200. So you can compute for F1X and F1Y. Okay, so the next step is just as I mentioned earlier. Since F2 is unknown, FR is actually equals to two forces combined, right? So the X will be FRX minus F1X. Okay, the Y will be F2X is equals to FRX minus F1Y. Okay, so the Y component one side, the X component one side, you will get these two. Okay, so you already have all your values in red over here, right? In red over here. Okay, so what you need to do is basically put inside here FRY minus this minus this, we should get this result. Okay, and once you get this result, right, the next point is you have F2 and F2X and F2Y already. When you have the component forces for each, okay, you have F2X, which is negative 387, and the other force is I have F2y, which is up, right? Which is from here you go up. Okay, 270, 278. Right? I'm not adding in any. So that means this will give me a resultant of force of what? Okay, so my resultant force will be something here to here. Right? In order to so this is my F2. And since this is a right angle triangle, you have the X, which is this. You have the Y, which is this. Right? You can easily use Pythagoras theorem. So Pythagoras theorem, F2 will be equals to Fx square plus Fy square, right? And root it. So this is Y over here. F2, you root it. And the tangent, obviously you use inverse tangent. The standard formula for inverse tangent equals to, you can find the theta, right? Which is Fy over Fx. And this formula is evergreen. Okay, because it's just using Tokaso we are approaching, right? And the formula and the angle here will be which angle? Okay, the angle here will be this angle. Okay, which is the theta we are talking about. Okay, this is the theta that we are talking about. Okay, so with this you can easily solve for force 2. Okay, let's move down to the next one. Question 3. Basically you just resolving your forces to the x and y component. This one very simple. Just plug in the values from there. You can read the x and y forces. You should be able to solve it. Okay, and the next thing is I go straight to question 9 for MCQ. Okay, you're taking moment about A, right? Okay, let's say if you take the moment about A, hang on, I need to select everything. Clear the board first. Okay, if you take the moment about A, okay, or A here, okay, so which means I have a moment coming down from here, right, which is from 20 Newton. Okay, the initial basis given to us is that this is 0.6 meter away. So in principle, the moment turning this direction is 20. I always put an A here because moment about A is 20 multiplied by 0.6. So it give me 20 and 12 okay, Newton meter. Okay, so this is the moment. So regardless how I shift my points to any of these points here, okay, if I were to shift to here, whichever distance I have, as long as if they maintain the weight of this, right, okay, the force applying here is still 20 Newton, right? So the force applying downwards is still 20 Newtons, but the moment will be 12 or so. And to make sure that it maintains the same aspect, right? So which means this will be also this direction. Okay, so this is for question 9 for the MCQ. The rest I think you should be able to try out. Okay. Practice question similarly to the question 1 which I mentioned earlier. Okay, the resultant force is always all the component forces acting together, right? So what we are doing right here is basically first part we need to refresh the Tortoso formula. So if you want to find the resultant force, basically is the x and y, the square root. Using Pythagoras theorem you can find it, and this tangent theta, right, which is actually equals to the fy over fx. So you use inverse tangent, you can find the theta. Okay, so this is a start off as a basis. Next point is to find the resultant force of these 3 forces. So just now I mentioned for 2 forces, basically you sum out the x, sum out the y. Okay, one quick approach is you draw a table like this. Okay, one column for x, one column for y. Okay, so if I have a column for x, if I have a column for x, if I have a column for y, okay, I annotate here. These are the forces. So if I have F1, one of the force, and F2, one of the force, we have F3, which is the other force. Okay, I extend the line a bit because I need a space. Okay, and then this will be my total force, right? So total force will be in the x direction and in the y direction. So that means this is what? This is F3 x, this is F3 y, this is my F2 x, this is my F1 x. Okay, so similar, this is my F1 y, F1, F2 y. So this is my total Fx. This is my total Fy. Okay, so this is this is the approach of how this particular table is formed. Okay, so because of this table measure, right, you see the diagram here. I have the diagram here to tells me the x and y direction of this. So with the x and y direction, right, and the assumption that was made, okay, with resuming you have this assumption, we always have this assumption basis, right, where the x and y up, right, and counterclockwise positive. Okay, then the next process is put in the so-called the signs direction of this positively. So that's why you can see the red marking here. Okay, the red marking here, red marking here, red marking here. These are the directions of the forces here. Okay, you put it properly, you just sum them up, effectively you will get your results. Okay, and then once you have the result, what do you do? Go back to resultant force again. Okay, because why? Same thing, right? Because this two is total fx, total fy. So this is total fx, this is total fy, right? So similarly, using this, you can draw your fr and the theta r, which is your angle. Okay, so this is for question 3. For question 4, okay, basically the only thing is that there are two forces. The approach you same, you need to find the component forces first. Right? To find the component forces, For 100, no issue because you have the angle, right? But for the 120 Newton, they give you a geometry. So how do you deal with geometry? Basically, geometry tells you, for example, I have this triangle given to me. This is my force pushing down. Okay, I know that this is 180, right? And I know that this is 5, this is 4, right? So what about this? What about this? The length of this. Okay, the length of this is the hypotenuse, right? Right? So the hypotenuse basically is equals to 4 squared or 5 squared, the square root, and you will get 6 point something over here. This is the one that I told you, this is a 6.4. Okay, once you get the 6.4, the hypotenuse, right, your main thing is resolved. Why? Because this is your theta, right? So sine theta is equal to what? Sine theta is equal to opposite over my hypotenuse. So I got my hypotenuse 6.4, right? Cosine theta will be 4 over 6.4, which is the hypotenuse. Okay, with all this you found already, right? Then everything will become very clear, right? So over here, you can see I plug in the cosine theta that I found, similar to here, and then the sine theta which I found, which is similar to here. Okay, and then after that, what's the next thing? Take care of the direction for both formula as well. Which one is negative? Okay, both are coming down, right? Both are moving down. Okay, both of the forces are moving down. Okay, they are all moving down. Whether is it for 120 or the 100, for both the y direction, they are going down, so implies they are negative. Okay, why? Because of our assumption is always this, right? Okay, so when they are negative, you put in the negative sign here. Okay, whereby you have a negative in red color that I shaded. Okay, this also have a negative that was shaded. Okay, so this is why there are red color marking down there. Okay, because these are negative. So once you indicate the negative and y, right, you have all these numbers that you resolve already. 1, 2, 3, 4, right? Basically, you put the 1, 2, 3, 4 back to the table. That was something similar to the earlier one. And this 1 plus 3 is equal to the total fx. 2 plus 4 will be total fy. Okay, and then summary again, right? So total resultant force using Pythagoras theorem of these two, angle using the inverse tangent of x y over x. So you can see the approach is always the same. Okay, question 6. Question 6 is the same of resolving of forces, except the thing that is tricky is that they tell you, okay, the boat is moving horizontally, right? So if in order for the so-called this boat, right, to move horizontally, right, it must be having two y forces that cancel each other, right? So the tugboat A and tugboat C, right, must moving on the same magnitude in terms of the y. So the y direction for A and the y direction for C must cancel each other. So this is why the FA y and FCY must be equal, or so-called they cancel each other to be 0, in order for the main boat B to move in horizontal motion. So that's why I have this formula called FCY plus FAY equals to 0. This is to ensure this is port B. Sorry for my drawing. This is B. To move straight. Okay, FAY and the FCY, they must cancel each other properly. Okay, and because of this, you got this first equation first, because you have tension A first, right, for A, and this is a sign component, this is also a sign component for C, and C is negative because one is positive, the other one is negative based on your assumption here. Okay, we have set the assumption here. Okay, so once you have these two, you have this first equation. The next one is they tell you that the tube B is moving at 5 kilonewton, right? So total Fx will be 5 Newton. So what you need to do is, oh, I have written something wrong. This is a 5. Okay, so please correct. This is a 5. Okay, this is wrong. This one, this is a 5. Okay, this is supposed to be a 5. Okay, let me see. I don't know if I can add here. No. Okay, just take note this is a 5. Okay, because this Adobe I can't add here. Okay, so I write it over here. The error, okay, TA cosine 30 plus TC cosine 45 equals to 5, not 0. 5, the error, there's a, yeah. So when this is actually having these two equations, right, you have TA and TC. TC and TA, you have two equations, you can use simultaneous, right, by finding one of the TA first or TC first, and then you put back into the two equations, you can find the other one. Okay, so these are basically doing it with simultaneous equation. If you are not familiar with simultaneous equation, basically if A plus B equal to C, let's say equal to 8 then 2A plus B is equals to 12. Okay, basically you can find, okay, you can just put this as 1. I just give you an illustration only. Then you can find B equals to 8 minus A, right? Okay, so if you express this in terms of A, you put the A into here, you put the B into here, right? So that means I put 2A equals to plus 8 minus A equal to 12, right? So putting this into here, okay, and then you get this. Okay, and from here you can find A, right, because there's only one unknown now. And once you find A, you put back to here, you can find B. Okay, so once you find A, you put back to here, you found B, because 8 minus A, right? So once you have this simple thing for this thing also, you find A, you can find C, you can find TA, you can find TC. Okay, next. Question 6. Okay, question 6 is is about non-concurrent forces already, where we started to talk about moments. Okay, when we have non-concurrent forces, most of the things is that it's working on a plane, and on a plane they are distance apart, and obviously we must use moment, principles of moments to, especially the Voronez's theorem. Okay, please read through what do I mean by Voronez's theorem. Okay, and this you are to compute the total moment first, because they are telling you that the Fr over here, right? The Fr over here. Wait, I need to undo. Okay. Okay, the Fr over here. Okay, this particular Fr. Okay, if this Fr is actually supposed to be the equivalent force that generate the same moment at this distance L. At this distance L. Similar to the rest of the 40, 70, 50 and 30 Newton that they can generate, right? So what you can do is basically set the assumption first. The assumption is this, right? Okay, so if you base on the assumption of this, basically you must find the total moment first. What is the total moment? And the total moment at this case, you must taking a moment about A. Okay, equals to what value? Right. This total amount moment, right? I'm talking about this particular one force, two force. Okay, sorry, I put A here. I have 3, I have 4, I have 5, whatever number of force I have, F1 to F5, let's say for example, Fn. That means I can say I can put any number and then what, and then this I must have multiplied by d1 all the way to d5, right? All the distance away, distance apart. So d2, d3, d4 and d5 for this. So the total moment will be F1, d1, yes, F2, d2, plus the rest you just add in if there are many forces. So down here there are 4, so basically you just add 4 moments. So when you have the 4 moments together, you sum them up, and after that determine the direction. They are coming down this way, so the moment is negative because it's clockwise. Okay, so you put, that's why over here I have a negative. Okay, that's why here I have a negative. Okay, so please do take note. Okay, and after that basically you just need to put it in and find for the length. Okay, find for the length. Or so-called the distance apart for this L, because the length multiplied by the 190 Newton, right, will be equal to the same moment. Okay, so this is for question 6. Question 8. This one is also a calculation of moments to balance each other. Okay, what I did here is for first part. Step 1, resolving the component forces for those that is not on the x and y axis. Okay, so not on the x and y axis, I have one here which is from the 30 Newton, right? From this 30 Newton, you have one force which is the 30 going this way. Okay, the 30x and the 30y, right? So when you have resolving these two forces, you need to find fx, 30x and 30y. And then once you find these two, right, because these two are individual component forces, they will generate moments, right? So what you need to do right now is from here, total moment You have how many forces? I have one force from the 70, right? Okay, moment generated, I have what? Moment from wall A. I will have what? Total moment about, at which point? 70 Newton. Okay, 70 kilonewton. And then I have the other one which generated from moment of F 30 y. Okay, and then I have, okay, I no space I put here, and then I add another moment which is moment from the 30y, right? 30y, so I have also moment from 30 x also, and then plus the last one which is the moment from the 60 kilonewton. So I have 4 moments to consider. So individual moment, if you put it correctly, this is for 70, this is for 70, okay, and then this is the y component, right? So this is the y component multiplied by the perpendicular distance away from the y component. So my y component is this way, right? Okay, my y component is measuring this. Okay, I draw the my y component is measured at this point, right? So, and this distance is perpendicularly away is 1.7. Okay, so this is the reason why 30 sine 28, which is the 30y, multiplied by 1.7. So the 60 Newton is actually 2.35 away. So 60 minus 2.35. And then the cosine element, which is the 30x here. So this is the cosine element multiplied by 2. Why 2? Okay, because the cosine element, right, is coming this way. I change the color to red. Okay, if it's f 30x, right? Okay, the x direction, what's the height from point A, perpendicular height away? This is actually given to you as 2 meter, right? From here, and once you get all these, right, you form your first equation for moment A. Okay, and then after that, please make sure you put the direction correctly. Put the direction correctly. Which one is positive, which one is negative? Okay, for 70, for first force here is pushing this direction, and the point is here, right? So this is coming down. Coming down means what? On clockwise. Clockwise is negative, and for the y direction it's also negative because it's on the right, right? And the 60 is also negative because it's also going to the right. And then the only force that's going to the left is the cosine element, which is the f 30x. So that's why this is the only one with the positive. The rest are negative. Okay, once you got this, you resolve the moment. The net moment is negative. Okay, and you want to find the location of that moment. Basically, you use the same moment, okay, divided by the distance apart. Okay, you actually find the moment of A already. So for B, basically the same thing, using the same calculation, but the distance apart is different now. But you were taking a pivoting point at A, at B. Okay, so you need to consider for B. Okay, this part I leave it to you to do, because once you know A, you know how to do B. Okay, for question 9, it's a little bit longer because you need to do a little bit more work. Okay. Question 9, what was given to in the diagram is this is the L bracket, and you are supposed to use the A as your pivoting point, right? And you see what is the component forces, so-called the total moment, right? Total moment about A, right? So the total moment about A will have incurred by how many forces? First and foremost, you must know how many forces first. You have F3, right? You have F3 which is affecting then you have I'm trying to find a tool. Give me a minute. Never mind. Bear with my right. I will write on the right instead. I have one force here which is from F3, right? I have another force which is from F1. Another force is F2, but F2 is a force that is actually not on the X and Y axis, right? So it can be resolved into the X and Y axis also. So every force that have a non-X and Y axis, not in the X and Y direction, right? I will resolve it first. Normally I will resolve the component first. So I find F2 straight away, right? Which is a slant force. If it's a slanted force, I just convert it to the X and Y component. The X and Y component very simple. Just now I taught you about the geometry, right? Which is the 5 and 12. So you convert back to the geometry, you can get the X2X, F2Y. So once you find F2X and F2Y, basically the same way as I did for the earlier question number 8. The question just before this, right? You find the moment for A. The X and Y multiplied by perpendicular forces are the forces. So once you find the moment, next thing is you find the total Fx and total Fy. So Fx and Fy is very simple. Basically, you just look at the force to the left or to the right, up or down, right? So 2x, the one that is on the horizontal axis over here, I only have 2x moving this direction at F3, right? So that's why down here there's only 2 forces involved, F2x and F3. And then for Fy, I only have F1 and 2y. 2y is moving up, F1 is moving down. So one of them is a negative. That's why I have a negative plus this. And if you do it properly, you will get your result to be 400 and 0. And this will tell you that because this is a positive, right? So it must be moving to the right. So that's why Fr resulting force will be only F is actually equal to Fx, which is 440 Newton to the right. And the net moment, if you want to say that there's a resultant force that actually generates the same moment, right? What is the distance away? If this resultant force is 440, so now basically very simple. You just reverse using the moment that you find over here, put it over here, divided by the force, right? So because why? Because moment equals to resultant force multiplied by the perpendicular distance, right? So this is 440. Total moment you already found out to be 164 Newton meter. So from here you can find your perpendicular distance away. And so with this, I have concluded the revision for this guide, this tutorial 2 guide. I hope this can help you along. Please do question 1 to question 9, and do take note question 10. I'm going to write it here. Question 10 and 11 are optional. So I leave it to you. If you want to attempt, please do it. Okay. If not, you will submit based on question 1 to question 9. Okay, and all the MCQ question. Okay, if not, thank you very much. Okay, I shall end the recording for this now. Thank you.